Good day. Welcome back to yet another session that we are trying to deal with the trial examinations in order to prepare you guys. So today I just sampled some of the trig questions that we can solve, different type of questions actually that we can try to solve together with all the explanations. If you haven't subscribed, please do so. Subscribe, share, and also like. It will help our channel to grow, and it will also keep us making videos for you so that you can ace your exams. So without wasting time, let's just get straight to it. We are behind time. So the first question that we sampled, it was proving the identity. So let's just see how we can do this identity. So this question, it seems hard, but actually it is not. It's 5 marks for free, 5 free marks. So let's see. So in this situation, you can see that we are trying to prove that this side is equivalent to that side. So how can you prove that? So I think the best way to prove is to first check your final answer that you want to prove as. And our final answer is saying 1 over tan of x. So if that's the situation, 1 over tan x, it means that you are trying to make this side equivalent to cos over sine, because you know that cos over sine, it is equivalent to 1 over tan x. So let's see how we can do that. So our left hand side here, yes, so let's just see how we can do this. So our left hand side, it is saying sine 2x. I think this pen is a bit too much. Let's just try to decrease that. So sine 2x minus cos x all over 1 minus cos 2x minus sine x. So let's try to change this, the 2x's, because we want our answer to be in x, not in 2x. So what is the value of sine 2x? The value of sine 2x is equivalent to 2 sine x cos x, and then subtracting cos x. And then this is all over. And also we can see this 2x, but below we said that we are trying to make our answer cos x over sine x. So we know that the value of cos 2x, it has 3 identities. So cos 2x is equivalent to 2 cos squared x minus 1, and also 1 minus 2 sine squared x, or it can be cos squared x minus sine squared x. So let's just try to place this in terms of sine, since we want our denominator to be sine. So this will be 1 minus, and then we said this is equivalent to 1 minus 2 sine squared x, and then minus sine of x. And again, this will be the top part. We can see that we are having the common factor, which is cos x. So let's factor out cos x. So this will be cos x, and then 2 sine x minus 1. If you factor out cos x, they will be left with 1 there. And then here we can see that 1 subtracting 1, these ones will give us 0, and the negative multiplied by this negative, it will be positive. So we'll be left with 2 sine squared x minus sine x. And again, this will be cos x 2 minus sine x minus 1, and the below part it will be, we can factor out sine x, so it will be sine of x, and if you factor out sine x, this will be, so this is just 2 here, so it will be 2 sine of x minus 1. So now we can see that we're having 2 sine x minus 1 and 2 sine x minus 1. So this and this can cancel out, and we'll be left with cos x over sine x. So what is our cos x over sine x? This is the same as 1 over tan of x. The same thing that you want there. So that will be our final answer for the first question. Very, very easy. You can see that these are free 5 marks. Are they 5 marks? Yes, free 5 marks. So let's move on to the next question. Now we're having this question with 7 marks. Simplification. We are simplifying. So when you're trying to simplify is the same thing as proving the identity actually. Just that the difference is that simplifying, we don't have the final answer, so it means that we can get it to any point that we want to get it to. But on proving the identities, we are having the final answer, so we are trying to get to that answer. However, this will be very, very simple. How do you simplify? You simplify each ratio by each ratio, 1 by 1 without a rush. So let's see how we can do this 5.1. So on 5.1, we can see that at first we're having sine of negative theta. A negative angle, mostly we take it as it is in the first quadrant. I mean in the fourth quadrant. So in the fourth quadrant, sine is negative, so this becomes negative sine theta. And then cos 420. 420, it is way past 360. So first thing we have to subtract by 360. So 420 subtracting 360. This will give us what? 60 degrees. So this is the same thing as saying cos of 60. So we can put that as cos 60. However, all the things that I'm doing here, you have to show them. Yeah, so it means that cos 420, you have to first put it as cos 360 plus 60, and then you can reduce, since this is the reduction formula, you can reduce to cos of 60, just like that. And then sine 540 minus theta, it means that also 540, we need to subtract it with 360. I mean 540 subtracting 360, what do we get? Subtracting 360 there, so this will be 1, and that will be 8, so it's 180. So this becomes sine 180 minus theta after subtracting 360 from 540, if I'm not mistaken. Yeah, I think so. So this becomes sine of 180 minus theta. So we are doing it ratio by ratio. Over sine 20, we cannot reduce sine 20 further, so this, we can just write it like that for now. So tan squared negative 120. So if you are seeing the angle to be negative, the first thing that you can do is to first add 360 to it. So if you say 360 plus negative 120, so we can have 120 there, and then we can add it to that. So what do we have? You can have 240. So this will be tan squared 240 degrees, like that, right? And then cos of 250. So 250 is the same thing as 180 plus something. We can use that reduction formula. So that will be cos 180 plus 70, like that. So let's see how we can simplify that further. So this still we are having negative sign, right? Let's use this color. So this will be negative sine theta, and then cos 60, we know that cos 60 is the same thing as half, so we can multiply that by half, and sine 180 minus theta. So what is 180 minus theta? We know that 180 minus theta, it is in the second quadrant, and our sign is positive, so this becomes sine theta, that is positive, multiplied by sine of 20 all over. And here we can see that we're having tan squared 240. So where is 240? 240 is in the third quadrant, so we use 180 plus 60. So what do we have when you say that we can get tan squared 240, so it's 180 plus 60. We still 180 plus 60 will still give us cos of 60. So let's just reduce the waste of time. Let's just place it as tan squared of 60. And here we're having cos 180 plus 70. It's in the third quadrant where cos is negative, so this will be negative cos of 70. Now we can simplify that further. So how now? So still we're having this negative, so it's negative, but sine theta multiplied by sine theta, this will give us sine squared theta, right? Multiplied by half, multiplied by sine of 20. And what is the value of tan of 60? If I'm not mistaken, this is root of 3, but it is being squared, so root of 3 squared, this will give us just 3. So this will give us 3 multiplied by negative cos of 70. Now what do we have? If you know the co-ratios, you know that sine of 20 is equivalent to cos of 70. So this and this can cancel, and we're having negative, and negative can cancel. So we are going to have half sine squared theta all divided by 3. So this will be 1 over 6 sine squared theta, something like that, right? Yeah, so I think that will be our answer. As we said, this will be 1 over 6 sine squared theta, as simple as that. So now let's move to our next question there. So in this question, it said that if 3 tan theta minus 4 is equal to 0, and theta is the element of that. So to solve that, we first need to take the ratio one side and all the numbers to the other side, right? So this will be 3 tan of theta is equivalent to 4, taking 4 to that other side, and now we can divide by 3, so it means that our tan of theta becomes 4 over 3. But now we are given this restriction. So how do you find the restriction, and how do you know where to draw your diagram? Because you know that in this question you have to draw the diagram. So what do? You can just draw your Cartesian plane like that. So we know that this is saying tan theta is 4 over 3, and we know that 4 over 3 is positive. So where is tan positive? Tan is positive in the first and in the fourth quadrant. So it might be there or it might be there. So you don't draw your solution yet before you can deal with the restriction. The restriction is saying that theta is the element from 90 to 360. So we know that our 90 to 360, it moves from, this is where our 90 is, to 360. So anywhere within these 3 quadrants is where our solution is. So already this means that our solution should be in the third quadrant, because it satisfies both of the restrictions. So we can place our theta there. But what is tan theta? We know that tan theta is equivalent to opposite over adjacent. So it means that this line now becomes our opposite. Which one is the opposite? It is 4 over 3, and 4 is the opposite. So now you can say your 4 there and your 3 there. But there's one thing also that you don't have to forget. This is the third quadrant. In the third quadrant, x is negative and y is negative. So you can place negative and negative. So it means that now we can use theorem of Pythagoras to try to find our radius. So we know that our radius squared is equal to our x squared plus our y squared. So r squared becomes our x being negative 3 squared plus our y, which is negative 4 squared. So r squared becomes 9 plus 16, which is 25. So square root there, square root there. Our r becomes plus or minus 5. But now we know that the radius will never be negative. So we are going to take our r as positive 5. So here this will be positive 5 there. So now we can deal with what we want to deal with here. They said we must solve for cos of theta. So what is cos of theta? We know that cos, it is equivalent to adjacent over hypotenuse, and our adjacent is negative 3 over 5. So this is negative 3 over 5, just like that. And then we can move to sine 2 theta. So what is sine 2 theta? Sine 2 theta, because here we're having theta, we don't have 2 theta. So it means that we can reduce 2 theta into single angles, not double angles. So sine 2 theta is equivalent to 2 sine theta cos theta. So this will be 2. What is the value of sine theta? It is opposite over hypotenuse. And our cos of theta, we have already found out that it is negative 3 over 5. So now we can multiply out. So negative multiplied by negative, it will give us a positive value. So 2 multiplied by 4, that's 8, multiplied by 3, that's 24. So this will be 24 over 25. Just like that. And here on this question, they said sine squared theta over 2. Now, how do we deal with this one now? How do we deal with this one? So we can see in this we're having sine squared theta over 2 minus cos squared theta over 2. So I think in this question we can try to manipulate it. It's hard, but it's doable. So I'll teach you how to manipulate these questions. So we can say this thing, let's factor out a negative, maybe. So if we factor out a negative, this now becomes negative sine squared theta over 2, right? And then now this becomes positive. So positive cos squared theta over 2, like that. So now we're having negative, so let's keep our negative. Now let's rearrange this. So this will be cos squared theta over 2 minus sine squared theta over 2. But there's something about this that you know, right? So this is the double angle of cos. What is cos? We know that if we're having the double angle of cos, so if this is cos 2 theta, we know that cos 2 theta gives us cos squared theta minus sine squared theta. But now if we're having half an angle, so it means that our angle was cos theta. What is cos theta? Cos theta is equivalent to cos half theta plus half theta, right? So this thing is the one that made us to have something like that. So it means that this, we can reduce it into cos theta. So this will be negative, and then this, as we said, this is a double angle in such way. So this will be reduced to just cos of theta. So this will be negative cos theta, and our cos theta already, we found out our cos theta to be negative 3 over 5. So this will be equivalent to negative negative 3 over 5. So our value becomes positive 3 over 5. As simple as that. This is very, very simple. How many marks are there? 4. Wow. Okay, let's move to the following question now. So right now we're having a question on proving the identity. Again, 7 marks. These marks should be free. You should get all these marks. So let's see how we can, or how you are supposed to deal with this question. Proving the identity. So this is the identity that we're having. So you can see that this side, the left hand side, must be equivalent to the right hand side. So now let me give you something that you must always do when you're having a situation like that. So the most complex side, it is the left hand side. So let's write that down. Is equivalent to 1 plus sin 2x over cos 2x. And we can see that in our answer we must have both cos and sine, right? So it means that when we are changing this, we must place them in a form of cos and sine. So that would be 1 plus, so sine 2x is equivalent to 2 sine x cos x. And then cos 2x is the same thing as cos squared x minus sine squared x. We can see that on the equation above, there's no way that we can factorize that, but we need to. So what can we do now? 1 is very important every time we're dealing with trig, because we know that 1 can give us sine squared x plus cos squared x. So we can replace 1 by that. So if we replace 1 by that, this means that this becomes cos squared x plus 2 sine x cos x plus sine squared x. So this 1 replaced into this and that. Can you see that? Yes. So 1 is always important when you're dealing with these identities. So now this is all over. We can see that we can factorize this. This is a difference between two squares. So this just becomes cos x minus sine x, and then cos x plus sine x. And this one, we can see that this was given by cos x plus sine x squared to give us this. So we can just factorize again. This will be cos x plus sine x cos x plus sine x, or this over cos x minus sine x, and then cos x plus sine x. So it means that these ones with the plus can just cancel out, and now we'll be left with let's just finish it in this way: cos x plus sine x over cos x minus sine x, which this is equivalent to the right hand side, like that. Can you see that? Very, very simple. So let's see how we can solve for 4.4 there. If sine 39 is equal to p, so this type of questions, you draw a diagram, which the diagram doesn't really need to be on a Cartesian plane. So what is the value of sine theta? We know that sine theta is equivalent to opposite over hypotenuse. So this p is the same thing as p over 1. So it means that our p is the opposite. So this is our 39, this is our 90, and this is our 1. So we can do this theorem of Pythagoras to find this unknown, which you can find it to be 1 minus p squared. So what would be the value there? We can see that that is 39 and 90. So 39 from 90 we get what? 51. So that would be 51 degrees. Now we can deal with this sine 129. So sine 129 is the same thing as sine 180 minus 51. So this will just be sine of 51. And sine of 51, we can see here, when we are here, what is the value of sine? It is opposite over hypotenuse. So this is just root of 1 minus p squared over 1. And tan 321. So this is the same thing as tan 360 minus 360 minus what? Minus 39. Yes. So this is negative tan of 39. So what is the value of tan of 39? So this is, when we are here at 39, what is the value of tan? Tan is opposite over adjacent. So this will be negative p over 1 minus p squared. Like that. So now we have to deal with sine of 78. So if you're having a value that you're not having there, because you can see that there we are having 51 and 39. But here now we're having 78. So when you're having that situation, you try to add them both. So if we add 51 plus 39, we get 90. So there's no, it is nowhere close to 78. But however, if we add 39 plus 39, we get 78. So this can be sine of 39 plus 39. So this will be the double angle now. So this will be sine 2 multiplied by 39. So what is the double angle of sine? The double angle of sine becomes equivalent to 2 sine 39 cos 39. So we look, what is the value of sine 39? The value of sine 39, it is p. So sine 39, it is just p. And then cos 39, it is what? Cos on 39, it will be root of 1 minus p squared over 1. So that will be root of 1 minus p squared, like that. And you can multiply out. So this is 2p multiplied by root of 1 minus p squared. As simple as that. These are free marks. I will continue after posting this because I can see that this is a long video. Can you please subscribe, share with your mates. Let's be one team so that we can be able to achieve what you want to achieve. This is your last lap in preparation trial. So you have to prepare for the finals. We'll be here till the finals. We'll make sure that when you write, when you are part of us, you are going to ace your exams. Have a lovely day.